welcome to the INCITS NIST workshop on the crosswalk of the NIST AI Risk Management Framework to ISO IEC 42001 AI Management System. I am David Bain, the Executive Director of INCITS, which is the International Committee for IT Standards. INCITS convenes the U.S. delegation to JTC1 for Information Technology Standards, including the U.S. TAG, the Technical Advisory Group for AI, representing the USA to ISO IEC JTC1 Subcommittee 42 for AI. As you can see from our packed agenda here, we have a deep diving workshop for you today with some world-leading subject matter experts in the field of AI standards. But first, I would like to acknowledge someone who's not officially presenting here, but nonetheless has been the wizard behind the scene to acknowledge John Calhoun from Microsoft. John first proposed this workshop some months ago, and John has been the chief instigator and driving force behind every step of our planning of this work. Besides being the force behind this workshop, John also serves on the executive board of INCITS and is the head of the U.S. delegation to JTC1 SC42 for AI. So thank you very much, John. We'd also like to acknowledge, in addition to the esteemed panelists whom you will all meet shortly, I want to acknowledge a few others that are behind the scenes from INCITS and from ITI who've helped get the word out about this important event. Lynn Barra from INCITS, Christine Reck, and Devin Fishburne from ITI. Earlier today, the Chief Science Advisor to the President and head of OSTP, Dr. Arati Prabhakar, made some important observations that I think are really germane to our workshop today. Dr. Prabhakar said that since the explosion onto the scene of LLMs, AI, unlike any other previous technology, has been so broadly recognized as being so impactful and transformational that when presidents sit down to discuss things, AI is one of the topics that they discuss, and this is of course unprecedented among our new technologies. She also emphasized that AI does not stop at the U.S. border and has a very important international dimension, and that standards are the way and the only way to address this very broad domain. And my view is that the family of AI technologies is like a quickly proliferating tree with many branches and flowers and perhaps a few thorns that is replete with opportunity for consequential engagement of people like you in the audience who are willing to roll up their sleeves, invest their time to go on this journey with us, to deconstruct this domain and rise to the challenge of developing standards, maintaining the standards, implementing the standards for responsible, safe, efficient artificial intelligence. So in that spirit, I recognize you in the audience for being with us today, whether you're joining us live today or whether you are watching a recording. We hope this recording will have a very long tail and continue to serve people in the industry for months and years and potentially years to come. So with that, I would like to introduce two very pivotal individuals in the AI standards space, Elam Tabasi and Rohit Israni, for their opening remarks for today's session. Elam, of course, you need no introduction. You're recently in Time Magazine as one of the most influential AI figures in the world. I happened to bump into one of your former staffers at NIST yesterday. Maybe I'll tell you later who it was, but she said, I don't know how Elam does it. It's like she's in two places at once. And I was thinking about the other critical and emerging technologies behind AI. And so either there's a cloning happening or you're using the quantum committee to achieve a superposition. Anyway, Elam, why don't you give your opening remarks first, and then we'll go to Rohit, the head of the INCITS AI committee, the chair of the committee. and CEO of Certient AI. So Ellen, take it away.
Thank you so very much for that super kind invitation. I wish somebody invents something that we can be in two places at the same time or teleport ourselves, but I just have been extremely lucky to have excellent colleagues, friends, role models, mentors. So thank you and shout out to everybody at NIST, our team. Some of my colleagues are on the call, Riva, others. I see some old friends also. So with that, I am grateful for all of you thinking about AI RMF, thinking about standards, thinking about providing alignments across all of this good work that's been happening, and look forward to the great conversation today. Back to you.
Very good. Rohit Israni, until very recently at Intel, is the CEO of Certient AI. Rohit, your opening remarks.
Thank you, David. And first of all, I'd like to thank INCITS and David for creating this platform where all the corporations in the US have come together to look at very important issues in AI. And I also would like to thank some of the other folks who are behind the scenes, but are a part of the overall effort that we have. This is the US tag to the SC42 effort, which has been very ably led by Wael Diab. And as the committee manager, we have Heather Benko. And again, a lot of people don't know, but the US is playing a key leadership role. The concept of doing AI standards was proposed at JDC 1 by US 6 years ago, prior to AI becoming the buzzword it is today. And thanks to the leadership of several of these folks, we actually do have 5 years of work that's been already done, and a lot of conversation topics that have become commonplace today have been discussed and deliberated on for the last several years. And we already have standards that are shortly being released, one of which we'll be discussing today, but a lot of other body of work, which is also very important as we look at the broad spectrum of AI and the issues that are becoming, common conversations, both with legislators, with corporations, and then also with consumers across the world. And so this is the very first workshop that we have, and I look forward to several more of those. And in today's workshop, we'll look at a very important part of the NIST AI Risk Management Framework and the AI Management System Standard, and how these two can be used effectively to put responsible AI in practice. So thank you.
So much, Rohit. And Elam, you are our first presenter. You're welcome to share any slides you may have at this time. And by way of housekeeping, as far as questions are concerned, if members of the audience have questions, we ask you to please type them in the Zoom chat. As we approach the end of every session, of every division of our workshop today, if we have time for questions, we will address them. If we don't have time, we will still very much like to look at them, and it's our intention to publish a Q&A document to share with everyone after the event, as well as the slides, as well as a link to this recording. So please engage with your questions, and we'll start off then now with Elam Tabasi from NIST.
Thank you, David. Again, welcome everyone, and thanks for your interest in AI RMF. Many of you that I saw the names have been with us during the journey of development of the AI RMF. I just want to give a very high-level overview, and I'm really looking forward to listening and learning from all of you, and super excited about the work of the crosswalks. So AI RMF, directed by a congressional mandate. Let me just see if I can, directed by a congressional mandate, the NIST AI Risk Management Framework is a voluntary framework for managing the risk of AI systems in a structured, flexible, and measurable way. It takes a socio-technical and rights-preserving approach because AI systems are more than data, compute, and algorithm. They are a complex interactions of data, compute, algorithm with the environment, with the context of use, with the individuals that are operating it or using the systems or being influenced and impacted by AI systems. To that lens, it's really important to discuss the risk understanding, particularly risk measurement and risk management from a socio-technical approach and just not from a computational or systemic approach. It's structured in terms of that the first part of the AI RMF provides the sort of a horizontal foundations, terms and terminology, taxonomy of risk, everything that's needed to be on the shared understanding on what are the risks, what are the AI systems, what we mean by trustworthiness, sort of giving an interoperable lexicon to talk about risk and risk management. Flexible in terms of not being prescriptive, being outcome-based, and allowing for innovation to happen, but also allowing to for entities and organizations with different resources to do risk management. The measurable attribute is particularly important for us at NIST because if you cannot measure it, you cannot improve it. So if you really want the end goal of the risk management to be promoting trustworthiness, we ought to be able to measure trustworthiness. So with that, development of the AI RMF was an open, transparent, collaborative process. As I said, many of you have been in this journey with us, and we are grateful and thankful for your engagement. Like many things that we do at NIST, we bring the whole community together. Rounds of workshop, draft for public comments. All of the interactions through the workshops and comments on the drafts are posted on our website for the transparency. We also ran listening sessions. One thing I want to emphasize here is that the community that we engaged, and we learned it very early on, needed to be a very diverse and expanded community that represent many different backgrounds and be interdisciplinary. So, of course, tech community skills such as computer science, mathematics, and stat were the community that we reached out. But beyond that, also the community that studies the impact of technology and AI systems, psychologists, sociologists, cognitive scientists, philosophers, again, as a nod to socio-technical approach to risk management and risk understanding. Overall, we heard from more than 240 organizations, more than 600 sets of comments, and the result was released on January 26. And at the time of that release, we also put out a playbook, a roadmap, and some crosswalk out. I won't go through all of this, interest of time. I'm going to move quickly. But as I said, the first part tries to provide a interoperable lexicon and bring everybody on a shared understanding of what do we mean by AI systems, what's the definition of risk. I will use this slide to say that the discussions about AI risk, AI risk management also overlaps with the discussions about risk management or risk management of the information systems or softwares. And also there has also been a lot of really good work happen parallel or before that. So in development of the AI RMF, we made sure that we leverage, align, use, refer to the many different good works that has been happened. So some of the definitions you see here are revised from the OECD definition for AI systems or from the OMB definition for risk. One thing I want to point out is the definition risk here allows risk to be positive, negative, or both, meaning that risk management becomes ultimately about maximizing the benefits while minimizing the negative consequences. So there's a lot of, I think, good content on the terminology and vocabulary that could be used, leveraged for next alignment or crosswalks that we're working on. The first part of the AI RMF also tries to unpack the concept of trustworthiness, get to the sort of lower level of answering the question of what constitutes trust. And while the conversations about what constitutes trust, what trustworthiness characteristics are, and some of you on the call have done extensive work on this, In consultation with the community, we came up with the 7 characteristics that you see on the screen: valid and reliable, safe, secure and resilient, explainable and interpretable, privacy enhanced, fair with harmful bias managed, and accountable and transparent as basically the basic building blocks of trustworthy AI. AI RMF provides some sort of a descriptive text for each of them, try to give more clarity on basically what it is to measure, and then later on get into the discussions on how to measure. It also talks about risk management challenges and some of the gaps that exist in the risk management and risk measurement. And top on the list is risk measurement. We don't have reliable, robust methods and metrics for measuring, for example, bias, interpretability, or safety of AI systems. And we basically have very little or no accepted consensus-based methods to assess the risk and impact of AI systems from a socio-technical lens. Many of the evaluations, or almost all of the evaluations that NIST has done and community has done, take the systems, AI systems, divorce from the context of use, bring into the lab, run test data, get the result, and analyze them. And I think we all agree that those type of evaluations will not be sufficient for assessing and measuring AI risk and impact. So how to do the testing of AI systems in the context of use, in the conditions and environment and humans and individuals that are using the systems or being impacted by the system, is a topic that we're actively working on. Other topics are risk tolerance. AI RMF, when it talks about kind of the different type of risk of AI systems, does not prescribe risk tolerance or risk thresholds. We believe that's depend on the context of use, values of the organizations and society and all that. So we don't get into the discussions of how safe is safe or how private is private. But in terms of the guidelines for risk management, we put it top on the list that risk tolerance and risk appetite has to be understood and kind of established as one of the first steps for risk management. Risk prioritization. So the previous slide talked about 7 characteristics. We loosely talk about trustworthiness characteristics and risk as sort of the 2 sides of the same coin. I know that that's not exactly kind of that mapping is not correct, but AI systems, in managing the risk of AI systems or to improving their trustworthiness, there is trade-off involved in those 7 characteristics that we saw in the previous slides. It's often the case that we cannot optimize all of them at the same time, and not for almost all of the systems. Singling out one of them is not going to give us the trustworthy systems that we want. There's a sentence in AI RMF that says that the trustworthiness is a spectrum, and ultimately it will be as good as its weakest trustworthiness characteristics. So it's important for the organizations to prioritize to risk and understand the trade-off among them, and also be able to allocate the right resources based on that risk prioritizations. One point here is that zero risk doesn't exist, such as zero error doesn't exist. So the resources should be allocated properly to manage the risk rather than eliminating the risk. And the last thing that I think gets more into the AIMS discussion is that AI risk management ought to be done next to or as part of the broader enterprise risk management or other risk management activities for managing the risk of, I don't know, cybersecurity or other risk of information systems or software systems. So we want to make sure that AI RMF can be plugged into enterprise risk management or other risk management processes that the entities have. But that's also a challenge, because right now the organizations have silos, and how you do that and what are the best practices and all of those questions. I'm going to go a little bit quickly, recognizing the time. AI RMF also talk about AI risk management being a shared responsibility for all of the AI actors across the AI lifecycle. To that end, again, leveraging the good work of the community, in this case, OECD, provides a kind of descriptions or dimensions of the AI systems, talks about AI actors involved in each of these dimensions from plan and design, collect and process data, build and use model, verify and validate, deploy and use, and operate and monitor, and also emphasis on continual monitoring of and testing and evaluation. So risk measurement, risk management is not an activity that's done once and then kind of set aside, because AI systems are not totally deterministic. There is data drift, model drift, emergent risk. So it's important to do it continually. I mentioned the OECD AI dimensions. Those are the data and input, AI model, task and output, application context. Those are the four. Again, having the a rights preserving approach and socio-technical lens, we put people and planet right in the center of these dimensions to emphasize the importance of understanding the risks and measuring the impact on people and planet. So that was part one of AI RMF, sort of setting that level setting, providing the, again, interoperable lexicon, understanding of what's risks, what do we mean by the different stages of the AI lifecycle. The second part of the AI RMF or AI RMF core provides guidelines, 72 guidelines to be precise, that are categorized into the four functions of map, measure, manage, and govern. The govern function in this figure, we put it in the middle as a nod to the importance of the govern function. We often say everything starts with governance, ends with governance. The goal of the govern function is to promote a culture of risk management, risk understanding, and risk measurement. So what we are hoping for is to make risk management as part of the culture, kind of go for a culture change that discussions of the risk happens at the earliest stage of the design, development, use, deployment, evaluations, rather than being a bolt-on. You have heard about security by design, privacy by design. We are hoping for trustworthiness by design. So what are some of the guidelines in the govern functions? That's roles and responsibilities are defined. Accountability line is clear. Policies and procedures and processes to implement the policies are clear. And it also talks about that successful risk management requires buy-in from the highest senior level executives. Those are the ones that basically set the culture. The map function focuses on guidelines to understanding the context, understanding the risks, understanding the trade-off amongst the risks that have the trade-off. So the risk prioritizations, risk thresholds, all of them happens during the map functions. These informations are being used by the measure functions and there are guidelines to quantitatively, qualitatively, or mixed method measurement of the identified risks during the map function. All of them comes to the manage functions that give guidelines on treatment or responses to the risk identified during the map and measured during the measure function. By design, we want to keep the AI RMF, as I said, flexible, technology and sector agnostic, and to the extent possible, future-proof or as evergreen as possible. That means that all of the guidelines are outcome-focused. It's not prescriptive. We also understood that more description and more explanations will help with operationalization of AI RMF. So Riva on our team had this brilliant idea of putting out a playbook that helps practitioner with operationalizations and implementation and use of AI RMF. So what it is for each of the guidelines in the govern, map, measure, and manage, it provides more text around what we mean by these guidelines, provides suggested actions, provide informative references and citations, provides suggestion for the transparency and documentations. I'll just note that the playbook, similar to AI RMF, is for voluntary use. It's not a checklist. Not everything in the playbook needs to be followed or implemented in its entirely. And organization can use it as much as or as little of and as much as they want. To keep pace with the innovations and fast pace of this technology, we intend to update the playbook every 6 months. AI RMF profiles are basically the verticals or understanding the importance of the context for risk management. And knowing that by design, we keep the AI RMF sector agnostic, we envision the development of the profile or basically, in case of the use case profiles, tailored set of the guidance in AI RMF for a particular use case. Examples is hiring, fair housing, financial sector. Temporal profile that kind of allow organizations to kind of track where they are in terms of AI risk assessment and risk management. But also we put a cross-sectoral profile for general purpose technologies such as generative AI, and that's what we're working with the community. We launched a generative AI public working group to develop a cross-sectoral profile of AI RMF. We also put out a roadmap of the activities that ought to be pursued. This has also been informed by input from stakeholders and everybody that was engaged in development of the AI RMF, and not surprisingly, alignment with the international standard and production of crosswalks to standards or other frameworks is top on the list. These crosswalks provide semantic alignment in the short term among the different documents, and it's going to be, I hope, very helpful and useful for the community that if they have two different documents, kind of say, okay, how they are relate to each other, longer term or medium term. I'm hoping that we can all work towards one single standard within, for example, ISO or other SDOs, rather than trying to have fragmented efforts to do the different activities and then try to do crosswalks. I will also note that expanding and strengthening test evaluation, verification, validations, in support of the measure function of AI RMF is the second and very close to the first item in AI RMF. Many of us at NIST personally believe that this is where the rubber hits the road. This is where, it's one thing to say what are the characteristics of AI RMF, where we want to go, but it becomes all about assurance and making sure that through some testing, we know the impacts, we know if AI system, for example, is biased or not, or safe or not, or private or not. We also put a resource center out that basically put all of our work. We're hoping that becomes a one-stop shop of the informations and resources need for risk understanding, risk measurement. Playbook is there. It's in an interactive mode. You can go and filter it based on the AI actors or life cycle or the functions. Please check it out. It's really cool things. Development of the AI profiles are being informed there, a glossary, a standard tracker, which we're working on, a standard hub, which we're working on OECD. All of them are there, and we're hoping that this will not only be a kind of information sharing from hub or center, but also a platform for engagement and continue the conversations we had with the community in development of the AI RMF into advancing all of the items on the AI RMF roadmap. I think I'll stop here. Oh yeah, that was my last slide. If I went extra time, I apologize. Thank you.
Yeah, thank you so much. We have one quick question that maybe we'll squeeze in right now, and that is a quick one. Will the U.S. develop an AI law like Europe? Was the question that came through, and I would remind folks, you may use the Q&A for your questions, and instead of pasting them in the chat, let's all use the Q&A function.
I quickly answer that question. NIST is a non-regulatory agency. Everything we put out are guidance for voluntary use. by a very wide variety of audience, from the technical people to policymakers. So if it's value to them, they can use it. I'm sure that they're following all of the happenings and energy in DC and Congress, many of the hearings. We'll see. But I think many of us in DC are now worried about shutdown. So rather than,
yeah, I wonder if a shutdown would affect the timing of any potential executive order relating to these questions, but it's all conjecture at this point. Thank you so much for that overview of the AI RMF, and I'd like now to turn for an overview of the 42001 AI Management System to Lenora Zimmerman from Google. Welcome, Lenora. Lenora, by the way, is the project editor of ISO IEC 27091 for AI privacy, as well as serving as the vice chair of the U.S. delegation to SC42. Thank you. Welcome, Lenora, from Google. Take it away.
Thank you for the introduction. All right, so I'm going to give a brief overview of 42001, which we affectionately call AIMS. So here's some background. So AIMS is a management system standard, which is different than your typical ISO IEC standard or just any other general standard. So with a management system standard, you start with a high level structure that has certain required management clauses, which on the right-hand side there, you see a chart there. So it talks about leadership, planning, operations, improvements, etc. And so every management system standard has that section in there. Each MSS is focused on a particular domain. Obviously, AIMS is focused on AI, and it really stresses that it's an iterative process. So for any system, there's an aspect of continuous improvement, not just of the system, but of the organization itself. And so that is another thing that an MSS really focuses on. An important thing, and I will probably mention this in multiple sections of these slides, is that it's a risk-based approach. So Annex A has all of the controls of AIMS in it, but the document is set up, the standard is set up so that organizations can take a risk-based approach based on their risk appetite, their environment, their operations, etc. The other really important thing is that an MSS is set up so that organizations can be certified by a third party, so you can be audited against it, even though standards are all voluntary. You know, I mentioned that the AIMS is specific to the AI sector. It was developed within Working Group 1 of ISO IEC SC42. And yep, so a little bit of timeline. So spring 2020, right when everything shut down, is when this was proposed as a new project. I won't go into all the steps, but it's actually progressed fairly quickly considering how critical this particular standard is for the industry. Right now, it's in its final draft. We expect the publication to be early of next year. And from a scope perspective, it is meant to be somewhat broad because of the topic area that it's covering. So it provides requirements, controls, that overview of management level controls, but it's for establishing, implementing, maintaining, and improving an AI management system standard or a management system. So again, it's a risk-based approach. It's just supposed to help the organization figure out, you know, if you're developing, providing, or just using AI, how can you do that responsibly? And what are the objectives you should keep in mind? What are the things you need to do to make sure that you're managing it appropriately? And And there's also an element of meeting applicable regulatory requirements, whether that be global or regional, other obligations that you may have, such as those built into contracts with your customers, and other directives that you may have in your region that create additional obligations for your organization. So some fast facts. So this standard allows organizations to define what does responsible AI mean for us. And it's all in the context of your organization. What do you do? What are you developing? What are you providing to consumers and customers? And although it provides high-level controls around, managing a system as far as continuous improvement and information sharing with third parties, et cetera, there is a huge element of responsible AI here, because that gets into how are you controlling it? What's the oversight? What are you doing from a bias and ethics standpoint, et cetera? But because it's risk-based, it provides a lot of flexibility for an organization to figure out how do we operationalize this for us. So although the controls are written at an abstract level, there is a lot of implementation guidance that is provided in here that gives essentially guidance and examples on how you would operationalize that, and thinking about, okay, if I take a risk-based approach, not all of these controls may apply to me. Some may not. And from, having an audit background myself, you should think about, okay, if I decide that this control perhaps isn't applicable because that's not what we do in our environment, you should document that and why you're not addressing that control. But it also allows the organization to provide that more granular detail on how they're achieving that control and what they're doing to operationalize it. So it's written so that it's not so prescriptive that everybody has to do things the same way, because that would stifle innovation. It could be technically infeasible for some organizations. And so that's the other thing that this standard does, because it's meant to be usable by organizations of any type and size. And so you have to consider that everybody's a little bit different. Some may be utilizing AI, developing it very heavily, and others may be using it in a much smaller context. And so having that flexibility to take that approach of what makes sense for us makes this a very usable standard. It was also written in a strategic way such that there are other standards within ISO IEC SC42 around risk and compliance and bias and ethics and controllability and auditability, et cetera. They're all meant to link together. And so this standard AIMS was written such that it can be used in conjunction with those other standards to sort of support how you would extrapolate on some of the controls that are written in this particular standard. So again, it's based on risk appetite, what makes sense for your organization, et cetera. And then when thinking about, since this is an MSS and it has controls in it and it is meant for certification and third-party audits, how are you going to build that into your GRC ecosystem? And this standard allows you to think about, how do I create a set of core common controls? So basically, what are my baseline controls that I can use that I could actually map multiple directives to? And when I say directives, I mean standards, regulations, region-specific laws and requirements, that kind of thing. And so when you're building a GRC ecosystem and you create that set of core common controls, it allows you to address basically when one control can meet multiple directives and multiple requirements. But also, if there are certain variations, which tends to happen regionally, you'll have some slightly different requirements in the EU versus in the APAC region, et cetera. How can we tie all those things in? And then as an organization, when we're thinking about how do we operationalize this, how are we being audited against it? How do we demonstrate our compliance? It allows you to do just a little bit extra to meet any different requirements you may have in other directives. So a little bit of difference in AIMS and the NIST AI RMF. I won't go too into detail because Kim's going to provide you a little bit more detail after me. The AI RMF is not meant for conformance or certification. However, a lot of the purpose of this workshop is to show how these two documents, these two standards, can work in sync with each other. So the system level controls and guidance in AIMS aligns really well with the AI RMF and also the requirements of the EU AI Act, which I know is top of mind for quite a lot of us. And so this provides a mechanism to show, okay, how do I match these things up, and how can I create synergies between these two standards? And it also gets to that idea of creating core common controls. So it allows you to map multiple directives to one set. So again, the AI RMF, it does not provide implementation guidance, but AIMS does. And then we're going to walk you through some examples in this workshop that will demonstrate how you can implement that. And yeah, I went very quickly, but that just means there's time for other presenters. So any questions or anything, or do we want to move on to Kim Lucy?
I think that we could accommodate a question. Let me see. Here's one from the question, the Q&A. How likely is it that government will incorporate into policy the standard, the AIMS standard versus the NIST RMF, and measure its private sector impact and effectiveness over time? Do you have any thoughts on that?
Asking the easy questions, I see.
Right.
I mean, if we're talking US, my personal thoughts is that it's going to rely more heavily on the NIST AI RMF. However, there are elements of AIMS that provide a little bit more information around controllability of the ecosystem as a whole. I don't know that I would see government rely on it so much, but I could see there be a strong reference to it in, like, if you think about government contracting, for example. I think, maybe you think 5 years from now, it's kind of like 27001. So all standards are voluntary. You don't have to do them, but it is very difficult to do business in many areas of the industry if you cannot demonstrate compliance and certification against 27001. So give it a few years, and I suspect that the same may start happening with 42001.
That's an excellent answer. 27001 is a wonderful precedent, as is ISO 9000 itself, sort of the one of the original management system standards. It does make sense to do something that has great international relevance rather than just being specific to one country. And with that, thank you so much, Lenore. You did a wonderful job. Let's turn now to Kim Lucy from Microsoft, so Ellen gave us the overview of the NIST AI RMF, and Lenore very kindly gave us the overview of 42001, which we now call AIMS. Increasingly, that's taking over the shorthand moniker for it all. And now Kim is going to give us an overview of the crosswalk. And Kim, as I mentioned, is from Microsoft, is a standards and GRC leader over there. Welcome, Kim.
Hello, thank you. Sorry, get this set up. Hopefully you can see that.
Kim Lucy has 2 sessions that she has bravely taken on to guide us through, both the overview and then transitioning from a 15-minute overview of the crosswalk straight into use cases, use case introduction and governance example. So thank you for taking both of those things on your shoulders, Kim.
Yeah, no problem. And just to check, everyone can see my slides, okay?
Yes.
That's right.
Okay, perfect. Yeah, so my name is Kim Lucy. I work in our corporate standards group at Microsoft, working specifically on standards involving governance, risk, and compliance. I have been working on ISO 42001, affectionately known as AIMS, as Lenora pointed out, for what feels like most of my life at this point, but since it started, so realistically, just the last few years. I also work on other standards in SC42. We have a standard ongoing right now on AI system impact assessments, have worked on standards around AI risk management, ISO 23894. I also work in SC27 for security and privacy. I am an editor on a standard on accreditation of certification bodies for ISO 27701, which is the Privacy Information Management System. So similar to AI Management System, but for privacy. So I've done lots of work in kind of general management system sphere. I have a kind of similar historical background to Lenora as well. I started my career as an auditor for information systems at Ernst & Young, have experience auditing management systems as well. So many years of experience dealing with management systems, and have worked a lot with NIST, both with 800-53 and various RMFs, cybersecurity, privacy, and now the AI RMF as well. So I'm excited to talk to you today about some of the work that we've been doing with the crosswalk or mapping, as we also like to refer to it, between AIMS and the NIST AI RMF. So with that, we'll go ahead and get started. So again, sometimes we refer to this as a crosswalk, sometimes we refer to it as a mapping. Essentially, what it is and kind of the thrust of the rest of this presentation is about a look at how ISO 42001 or AIMS and the NIST RMF align to one another. And I think both with what Ellum has gone through and Lenora has gone through, you've seen, there are both some similarities and some differences. Both of these documents are risk-based. One is a framework that organizations can implement to kind of help them put in place a system to help manage risk. AIMS is similar in that sense, but also is a certification-based standard that can be audited by third parties. There are enough similarities, though, that what we have found is that it's really helpful to map these things so that organizations can think about how they can be used together. So with that, and apologies, I'm kind of getting over a little bit of a cold. With that, just talking about some of the methodology and how we went about doing this mapping. AIMS is structured, as Lenora told you, with a set of requirements and controls. We took those and looked at the various NIST AI RMF subcategories within the govern, map, measure, manage functions. And then within each of those NIST subcategories, each of those can have a mapping to many AIMS equivalents. So it's not a one-to-one mapping. It's not each subcategory has exactly one AIMS equivalent. And I'll go through that. We'll have some visuals, but it's essentially a many-to-many mapping. And again, just want to stress this, that it's important to understand that while there are similarities, there are differences in these documents, how they're implemented, how they're used. And so I just, I think that the mapping is a really important tool. It can help organizations understand where there are similarities. It can help organizations uncover additional risks that they may not be thinking of. But at the same time, it's always a little bit of a double-edged sword, because when you do a mapping like this, I think sometimes organizations can see it and immediately think, oh, that means they're equivalent. They're the exact same thing. They're used the same way. And, we want to be careful, because that's really not the case. It's a little bit of comparing apples to oranges, and we want to highlight where the similarities are, but we also want to be careful that the documents are used in slightly different ways. So I do want to stress that point, as Lenora did as well. There is a link down at the bottom here. I realized that, that's not particularly helpful in this moment because you can't click on it, but it is a link to where NIST actually has this, the actual crosswalk mapping document posted. So you will be able to access that if you're super quick. You can write that down right now and access it. You can also use your favorite search engine to type in NIST 42001 crosswalk, and I think you can probably find it. So why would we map these two documents, especially if they're not necessarily used for the same reasons? Why would we even bother? So again, because both of them share a risk-based approach, which is really fundamental when you're dealing with AI and you have these systems that are new, and we don't necessarily always understand what all of the different risks and impacts are going to be. Leveraging different approaches to assessing risks are going to help your organization make better informed decisions about how to develop and use AI systems. So, kind of as many different ways that your organization can use to assess risks, figure out impacts, is going to be better for the people who are impacted by those systems and using those systems. A lot of organizations are going to have customer expectations for using different frameworks and standards. So organizations who are based multinationally, if you're based in the US, you are likely going to have expectations that you use the NIST AI RMF. If you're also based internationally and have to comply with the EU AI Act and standardization request, harmonized standards through the EU, you're likely going to have to comply with things that are based on international standards. Not saying that right now AIMS is necessarily one of those, but likely you're going to have to eventually comply with things that are based more on international standards. So, having customers based multinationally means that you're going to have to comply with different things. And having these things mapped so that you can understand the core similarities makes it easier to say, okay, here's how I can implement this, understand where the similarities are, satisfy the needs of my customers who expect various different things, and not have to do a bunch of extra work. Additionally, it's continuing a long history of collaborative crosswalks between NIST and ISO. So the cybersecurity framework, the privacy framework, there are mapped crosswalks between ISO and NIST documents 27001, 27701. So there's been a really long history of this collaborative effort in mapping these documents for the reasons that I just mentioned above. So this just continues that history. Sorry, again, excuse me. So this is an example. Hopefully you can see that. I know it's a little bit small. These are essentially just screenshots. So on the left, I've taken a screenshot out of the crosswalk document that's posted of the NIST AI RMF to AIMS. And this is just a small piece of it. We have some examples here from the govern and the start of the map sections. And what I wanted to show is, so for govern 6.2, we've got it mapped to B10.2 and B10.3 from AIMS, which are allocating responsibilities and suppliers. So if you look at the crosswalk itself, this is really all you get. You just get the control title. Unfortunately, because there are copyright issues with ISO, we can't publish all of the details. You don't get the full control title. You don't get all of the implementation guidance. You have to go and buy the ISO standard for that. Unfortunately, there's nothing that I can do about that. But once it's published, do go and buy the standard. I have included a little snippet here so you can see, you know, when you extrapolate the full information, what that actually looks like. When you look at this govern example, contingency processes are in place to handle failures or incidents in third-party data or AI systems deemed to be high risk. So we're really talking here about failures or incidents for third-party data. So thinking about relationships with third-party suppliers. So thinking about allocating responsibilities with your third-party suppliers and suppliers in general. So that's why we've mapped these two specific controls. And when you go into AIMS, you can see more detail here, the control wording itself. So ensuring responsibilities with your suppliers. So throughout the whole life cycle, making sure that you've allocated the appropriate responsibilities to your suppliers, partners, customers, third parties. And then also that those responsibilities that you've allocated actually align with your own approach to responsible AI. And then you can see, you know, Lenora mentioned that a lot of the details are in the implementation guidance for the control. You can see there's one example here, and we've got like 3 paragraphs of implementation guidance, which really goes into a lot of this detail. And all of that taken together really maps back to, you know, to what the gist of this govern 6.2 control is getting at. Similarly, looking at map 1.1, we have intended purposes, beneficial uses, context-specific laws, norms, expectations. It's a fairly long example. And for this one, we have a number of different, looks like 5 different controls from AIMS mapped here. And I've pulled out 4 of these from AIMS to show you the not all of the implementation guidance, but the controls and controls wording. These are all around AI system impact assessment process controls that are within AIMS that talk about establishing a process to assess potential impacts, thinking about potential impacts to both individuals, to societies, actually performing and documenting the impact assessment. And we have a couple of presenters who are going to talk later in more detail about the whole impact assessment process. But you can see that all of these controls in AIMS actually tie back to the details in this MAP 1.1 requirement. So I'll pause here for a second before I go into my next section. I don't know if we have time, do a time check. I don't know if we have a moment, if there's one question, David, we want to address, or if you want me to go directly into the next section.
We can pause for a moment, let you catch your breath, and take a quick question. And we do appreciate your weathering through the season sickness to be with us today.
Yeah, I feel fine. It's my fifth grader going back to school.
Boy. How about this one? I'm looking at the list of questions. So for a commercial organization that is using AI, who would be the typical person, i.e., what's their title, who would feel a business imperative to implement either the NIST framework or the AIMS standard? And yeah, do you have thoughts on that? Well, for one, the one potential title is the next speaker after from IBM after you finish the next section. But do you have thoughts on who would the roles be?
Yeah, I mean, it really depends on how your organization is structured. A lot of organizations are starting to have responsible AI organizations, and so someone in that organization, would be definitely interested. There are also compliance arms. That would be, at Microsoft, it's a little bit complicated because we have both. And so there's lots of calls to implement things from all over the place. But, compliance leads are very much a part of this because it gets very interconnected, because a lot of times the initial calls will come from sales and marketing, and they're saying, hey, we're getting questions from our customers about, have you heard about this? Do you have this certification? Do we comply with the NIST, or have we implemented the NIST RMF framework? And then that gets trickled down to the compliance teams and the responsible AI people, and they say, yeah, we should start planning for this. And then they filter it down to the engineering teams, and the engineering teams start implementing it. So I think it's not just one person or one title. It can sometimes come from originating from sales and marketing first, but it can also sometimes originate from responsible AI or compliance. It just depends on kind of where your organization is at and who has the leverage at that particular point. But it's really it will have to be a joint effort, because all of these roles are intimately connected in actually implementing this successfully. I don't know.
That's a great answer, I suppose. And as expansive domain as artificial intelligence, I suppose it also may depend on where the technology, which branch of the technology affects which divisions of your company. Is it a compliance or other issue? But thank you for the question. Yeah. And maybe let's move on with the next part of your presentation. Yep. Thank you.
Of course. All right. And so the next part I'm going to talk about is, now that we've introduced both the NIST AI RMF, ISO 42001 AIMS, as well as how we've mapped these things together and what that looks like. Now we're going to walk through how might you use that mapping? if you were an organization and you had a particular use case, and you had you had implemented both the NIST AI RMF and 42001, what might that look like with this specific use case? So what I'm going to do is walk you through the use case that we've come up with, give a brief introduction to that, and then I will walk through a brief example using the govern function and some subcategories of that, and then turn it over to the rest of our speakers who are going to walk through the rest of the various NIST functions using the same use case. So as I mentioned, the rest of this presentation will kind of use that same use case to structure it. All of the various functions, govern, map, measure, manage, we will use the same use case. And we've come up with a narrative. I've put that on the slide here. I'll kind of read through it quickly. And just as kind of an FYI, we've knowingly built in some holes in this narrative and the relevant info to knowingly introduce some risks. So as you hear this and read this, you'll probably say to yourself, that doesn't sound maybe like the best use case, or maybe there are some things missing. That is by design, because as we go through this, we want to be able to show that the RMF and AIMS actually help help you identify these risks and these holes in the system. So with that, the narrative that we've come up with is essentially a building entry system that allows authorized people to enter through a locked door. The system uses high-resolution digital cameras at the door along with facial recognition. The facial recognition system is built on a neural network trained on photos of the authorized people and a broader set of photos of unauthorized persons. The system compares these images captured by the door cameras with images of authorized people and unlocks the door when a positive match with a high probability is made. In the event of a false negative, the authorized person can gain access by contacting building security personnel. And then just some other relevant background info for the data source. The training data is obtained from photos taken of authorized persons. Production data is obtained in real time from digital cameras at each door. And then for the data quality, efforts have been made to ensure the training data represents people with different skin colors, genders, national origins, ages, and statures. We're not clear how well the training data represents diverse facial features, such as glasses, facial hair, jewelry, and tattoos. So keep that in mind as we go through this. And then to kind of help you visualize, we have this diagram that shows kind of the system architecture. I won't make you memorize this because each of the speakers is going to have the system architecture in their slides. It will come up over and over again, so you can kind of have a visual reminder of where the AI model and training data set, the test and verify, all of that is located in the system architecture and how it kind of flows throughout the system. So you'll see this over and over again. So walking through one example in the govern function, and this is actually the very first subcategory in govern. So what I've done here is taken the govern 1.1, which is legal and regulatory requirements involving AI are understood, managed, and documented. In the crosswalk, the AIMS controls and requirements that are mapped to this particular subcategory are 4.1, understanding the organization and its context, 6.2, AI objectives and planning to achieve them, B.2.2, AI policy, and B.2.4, review of the AI policy. So those are the four for controls and requirements in AIMS that we've mapped to the NIST AI RMF Govern 1.1. Then what I've done is to go through as if, I was a, say a compliance person working at this organization with this use case, this building entry system, and thinking about, this particular use case and what I might think about for each of these controls and requirements. So thinking about 4.1, understanding the organization and its context, which in 42001 is really about making sure that you understand where your organization operates, the consideration of your particular stakeholders, laws and regulations in your region, so very relevant to Govern 1.1. So what I've come up with for this particular use case is the organization using the building entry system should understand the laws where the system is in use, including if they have multiple locations in different jurisdictions. And this is really important because if you work in an organization, for example, where you have locations in Europe versus the US, and I'm thinking particularly, I used to work in our data center group in Microsoft, and we had very different rules for, how long we could keep records of entry logs in data centers in, say, Amsterdam versus the United States, because there are different laws about how long you can keep that type of information in the EU versus the US. So that's something that for this particular context, the organization needs to be aware of. So next one, 6.2, AI objectives and planning to achieve them. So what are the organization's objectives relating to the use of this system? Is it accuracy? Is it legal compliance, if that's applicable? Fairness? And they also need to document these so that the objectives can be integrated into all the layers of the organizational planning and execution. So this is an internal system. Maybe fairness isn't the most important objective to the organization in this case. Maybe accuracy is the most important. Whatever that is, the organization needs to think about those and document them, make sure that those objectives, again, are integrated into the various phases of what they do, system design, system implementation, make sure that the rest of the organization is aware of them, and that also that it ties in back to 4.1, that it is compliant with anything that, requires them to be compliant with the law. So B.2.2, AI policy. So the policy should be documented, available to relevant interested parties. It should also include information on what laws and regulation the organization has to comply to, how the system does so, any relevant considerations that must be taken with the system to ensure the compliance. So, for example, not keeping images used to train models longer than however many amount of days. This is important so that all the relevant people in the organization know that they have to comply with the law, how they comply with the law, and if anything changes, that documentation is kept up to date so that they can remain in compliance with the law. That also leads into B.2.4, which is review of the AI policy. So it should be reviewed periodically to make sure that it stays in compliance with any changes to the law, that changes are made, also if the system changes, et cetera, et cetera. So taking all of these things together, if you read, all of those details in the third column, all of those items really help you comply and help you generate the documentation that Govern 1.1 is actually going for, and the intent of 1.1. So as you're doing, as the organization, if you're an organization who has implemented both the NIST AI RMF and are doing ISO 42001, you've generated, controls, you've generated all of this documentation. You're not only complying with 42001, but you're complying with the intent of the NIST AI RMF as well. You have understood your legal and regulatory requirements, you've managed those, and you've documented those through all of the stuff that you're also doing with 42001. And this mapping really helps you understand that, so that you're not, after the fact trying to figure out, well, yeah, I think I'm doing this stuff, but how can I really prove that? So what the crosswalk does is really help facilitate and show that, so that, after the fact, you don't have to try and figure out, how am I complying, or how am I documenting my risks and my documentation with the NIST AI RMF. The crosswalk helps you do that by aligning this already. And I think that's my last slide. So hopefully I haven't gone too much over time. Not sure if we have any time for a question, but
I think we're in good time. We're not too much over here. To work on to go a little further with your very last point, did I hear you say that if an organization is compliant with 42001, that they would automatically be able to consider themselves complying with the RMF?
So that's, and I do think I said the word compliant, and that was bad of me. That's not the phrase that I want to use, because again, the AI RMF is not a document that we want to say, oh, you're compliant to, because it's not a conformity assessment based document. You can say that that you align to it. You can say that you've implemented it. I guess what I'm saying is that, if you have implemented AIMS and you've implemented the AI RMF and you're doing both of them, you're by nature generating the same type of documentation. If you go the next step and get certified to AIMS, you're likely generating the majority of the type of documentation that you would need to also be able to successfully implement the NIST AI RMF. And I'm not going to go as far as saying, yes, absolutely, you could successfully 100% implement the NIST AI RMF if you're doing AIMS, because there are nuances. But I think if organizations, especially if organizations look at these mappings in conjunction, implement them kind of in conjunction, and think about how they approach risks in conjunction with both of these documents in mind, they're going to be a lot more successful, not only in how they manage risks of AI systems and for their customers and stakeholders, but also in being able to say, yes, I've successfully implemented the RMF and I successfully comply with 42001.
Very good. Thank you for keeping us straight on the nuances of the language. We might need to put a jar that people have to put $1 in every time they say comply with.
And I'm the biggest proponent of not doing that. So I'll put a $10 bill in.
So thank you so much, Kim.
You're
and
welcome.
We're so happy now to welcome Mariel Acosta Geraldino. The question came up earlier as to the type of person, the role in a company that would actually be faced with having to track the compliance requirements across different technologies, including AI, in different countries. And well, that person is right here with us. And we're so pleased to have you, Mariel. And you'll be giving us a more in-depth map example and bringing to bear your experience and perspective as a corporate program manager for all of the Americas at IBM. So welcome. Need to unmute, yes.
Yes. The next stage in the risk management framework, it's a map. And you've already seen this, you probably memorized it already from the presentation that Elham had, but I decided just to refresh you so that you can see where map it's located into the diagram and how it relates to all the other factors. The map function establishes the context to frame risks related to an AI system. And a lot of people that just want to dive into what are the risks have a little bit of an issue dealing with all the paperwork that they have to gather in order to understand the context. And it always helps me illustrate the point of the importance of the context when I think about the risks associated with AI being used by a 12-year-old versus a person that is over 30 years old. So I know paperwork may not be your cup of tea, but it is very important in order for you to frame the risks. The way that I see it on this section, you have two items going into the function. You have the context, you have the risk, and the function serves for you to make a call. You will gather tons of data in this stage, but this data is going to be fed into the later stages, into the later functions, the measure of manage. But the very important thing coming from a compliance point of view is that this step is going to validate whether or not you have everything you need to proceed in the development of a responsible AI. Okay, I would have loved to show you a graphic representation on IEC 42001, but they don't have any graphics at all in that document. So you're stuck with words for this one. In this particular case here, and Kim had this particular example of map 1.1 on her presentation. And this is a map for the section 1. So you have the RMF and the 42001. You can see here why I said that there is a lot of documentation, the business value definition, the organization missions and goals. And I see that a lot of people in the Q&A are focused on which one should I use? Which one? And I don't think you're going to get that answer, at least at this point in time. We have to wait until we see what is going to be mandatory and what laws and regulations appear in different parts of the country. The ISO IEC is actually an international standard, so you have that going for you. It does give you the international world, but it, as Kim mentioned, it is a conformity assessment. So it has some management. So it is an overall, whether the NIST AI RMF, it's more of a risk management. And you can see, just for reference, there is a document being developed for anyone who is just interested in risk management, and it is called it's the ISO IEC 23894 AI risk management. But at this point, I would not be bogged down for which one should I use, because there are a lot of things that are complementing from these two documents, and the fact that you meet with one is going to have you ahead of the game in terms of, for example, documentation that you need to gather and controls that you need to put in place to prove to an auditor that you are doing what you need to be doing in order to develop a responsible AI solution. So this was just an example. Let me now go back to the case scenario that we are covering in this time, and try to show you where in the different sections of each document you're gonna find both documents being touched upon, right? So on this particular one is map 4.2. The slides have all of the correlationship, but you can find it on that link where you see all the crosswalk, how each section goes from one to the other. And map 4.2, it covers the internal risks controls for components of the AI system, including third-party AI technology. And on this particular case that we have here, you would think like, where do I set this up? So for example, with the data subjects, we covered that it was presumed that the training data set included different races, people of different races, different height. So you're trying to cover all possible solutions so that you have really good representative data, okay? So B627 on ISO 42001 would be where you would find how you're going to be documenting all those details, that the information those points were taken into consideration before you develop the training data set. And that will be over here. This is mostly a function of the developer of the AI solution. Now for B82, and that is system documentation and information for users. And for someone who is in development, sometimes it is difficult for them to visualize how you have to go from end to end. So first you're working on thinking about the training data. And then suddenly you're talking about what documentation do I need to provide for the users? And Kim covered, I think, a little bit of this. It's like, now you have all your system put together, but the facial image, what kind of instructions do you need to give to your end user? Do you need, for example, for them to remove a hat or sunglasses, or the very controversial mask? What instructions do you need to provide to them? Or a hat, removing a hat, easy, right? No one is going to get offended. But what about something that is cultural? For example, a hijab or other types of head coverings that are culturally mandated. So those are points that you need to cover, and that would be on the end user side, and maybe the developer is going to have some trial clients and figure out some input from third parties, not only developed in-house. And then the last one is the supplier, and Kim touched also on the suppliers. The suppliers is very important because there are a lot of companies that think, well, this is my part of it. I meet with all the regulations, but it goes beyond that. If you're using a supplier, you need to ensure that the supplier meets with whatever good practices you have in place. And what if they don't? Then remember that diagram that I showed you, go, no go. It may be a point where you have to stop and then find a new supplier, or put your program on hold until the supplier that you chose has some fixed, caught up with the times. And so I am here listing the one that Kim showed was B, the Annex B. Also in Annex A, there are some categories that talk about the suppliers, and you need to understand that your organization, the organization that is developing the solution, you need to make sure that the providers, that all the suppliers down the line also have some kind of a process that aligns with your organization's approach on development of responsible AI. Okay, so now I don't want you to get depressed. Let's just think that your supplier meets with your processes and it is a go on the decision. So now what else is there? This chart here shows section 2, map 2.1, and these are the specific tasks and methods used to implement the support for the AI system. And then the correlation to 42001 is listed here. I find this is a good point, you know, how it touches on human resources on B46. It touches on human resources and what kind of people are working on this document. And then the documentation, I think eventually there will be some kind of leverage with ISO 9001. That is a quality standard that develops, that has a whole bunch of documentation. We've used ISO 9001 to meet with certain sections on ISO 17025. So eventually, it will have to be customized for AI, yes, but it doesn't mean that your company has to start from scratch. Then this is another one, map 2.2, talking about the AI system knowledge limits and how systems outputs will be utilized and overseen by human. This is huge because you want some accountability. You want to be able for learning algorithms to whatever it is that is, whatever you are feeding into the learning algorithm, that you are able to explain it. And you know, in case of an audit or in case of a failure, you are supposed to learn that. And then this last one is on section 2 is the, I think, if you're coming from development, it's like, okay, so now we're getting into it, you know, like now system verification and validation, which may surprise you that it's also on map, because I did mention that it's a lot of system documentation, right? But here, when you go into the ISO IEC 42001, you're going to have also B624, which is AI system verification and validation. And these I will cover into a little bit more details. I do have the chart here. If you see the last 4 rows, you have like 5 rows here that are related to the Annex B72. And this is the data for development and enhancement of the AI system, how you're going to be acquiring the data, what is the quality of the data for the AI system. So in the particular example that we had, you have, we would put it right here, also is going to be falling under the shoulders of the developer of the AI. And then the system verification and validation, that's 624, and showing you the clip from the 42001 where the control is listed and how you should define the documentation. Now, with that said, remember I mentioned the context is there, but also the risks, right? And then the risk definition, just pay attention to what definition you're using, and notice that Elham covered that risk. It doesn't necessarily have a negative connotation. It may be a risk associated as to having an output that was not expected. Maybe good. For me, I'm coming from the product safety world. For me, risks is always associated with negative, but just the point that I'm trying to make is just keep in mind, you need to read the definition of risk that you're using before implementing so that there are no confusions. Then the different environments where that risk may affect others. And you're going to have to go into identifying each risks and then do an assessment. How likely is this to happen? How bad is it going to be if it happens? What safeguards, what measures can I take to control the impact of if this risk were to become something real. And what I really like is, again, and this comes from the RMF, and both documents cover it, but there is that detail about tracking emergent risk. And there was a big storm, right? And the electricity went down, and the electricity went off for, I don't know, 2 weeks. There was no gas for the generators. And now you have your system, very good system, but you cannot power the system because your electricity failed and your backup generation failed. So those are some emergence risks that you would need to take into consideration of how to operate the application if something like this were to happen. Okay, so now I didn't go too much into risk because the next two speakers are going to cover the impact assessment in detail. I will stop sharing now so that they can go into the risks as part of it.
Thank you. Thank you so much, Mariel. And you are such a wealth of knowledge when it comes to the practicalities of implementing these things as you do across so many countries. And I encourage folks to put their questions in the chat that we'll get to. And now we do turn to our academic experts, Dr. Anthony Barrett, Tony Barrett, and Dr. Daminda Wijesekera are with us here to guide the discussion of AI systems, risks, and impact assessment. I'll just add that in addition to his affiliation with Berkeley, Tony has a long-term worthy and commendable affiliation with other initiatives like the Berkeley Existential Risk Initiative and the Global Catastrophic Risk Institute. And Dr. Wijesekera, whom we sometimes call Doctor because they didn't let him go away from Cornell before giving him 2 PhDs. He is an expert in also applications, including the cybersecurity side of things, and I just can't wait to see what you guys are going to cover. Thank you.
Thank you very much, David, and thank you to everyone joining us today. Appreciate the opportunity. I was a risk analyst and government contractor in the Washington, D.C. area, supporting federal agencies, doing various types of risk management for many years. And so I think for anyone I'm going to be talking a little bit about risk assessment and impact assessment, specifically in this context of the NIST AI Risk Management Framework and ISO IEC 42001. I think many of the basic ideas here are going to seem fairly commonsensical to many people who have, especially if you have experience doing risk assessment or impact assessment in another domain. Just a quick terminology note. I'm going to be talking about risks and impacts. The different communities, different communities of practice, and people working in different domains often use these terms in slightly different ways. Here, broadly speaking, I'm going to be talking essentially about a risk as a roughly synonymous. Risk is roughly synonymous with a potential impact. As Mariel mentioned just a couple of minutes ago, those potential impacts can be positive or they can be negative. And usually, as risk analysts in other domains, we're worried about potential harms. So usually I'm going to be talking about risks, the examples and so on, as potential harms, potential adverse or negative impacts. And so typically, we're with both risk assessment and impact assessment, we're trying to ask and answer as best we can the same types of questions. When we have this AI system, it's developed and deployed in a particular area, in a particular context, what could happen, what could go wrong when we're again talking about potential negative impacts. Who could that affect, or who could that impact? How bad could that be? What would the magnitude or criticality of that be? And how likely is that to happen when we're talking about potential impacts? And in some cases, of course, some of those risks may be realized. We may see actual impacts occurring, in actually causing harms to people and so on. Oftentimes, as we get into a risk assessment or impact assessment process, we already, even before we start the formal process, we have some idea of the kinds of things that could go wrong. So here are just a quick list of the kinds, illustrating the kinds of things that might go wrong, the kinds of potential impacts that we might see with this use case that we've already heard a bit about. We'll talk about these in a little bit more depth, both here and in the following presentations. So, for example, there could be issues with collection or processing of unenrolled people. The system could put false reject people at a significant inconvenience. And by the way, the false rejection or false accept rates could be different for different groups of people. There could be biases because of skin color, for example, that's been observed in real world facial recognition systems already. There can be security risks, for example, from false accepts or presentation attacks, and so on. I'm not going to be giving you an in-depth tutorial on how to do impact assessment. I'm going to be focused more on the crosswalk, but the correspondences, some of the places where we see correspondences between impact assessment in the NIST AI Risk Management Framework and impact assessment in ISO IEC 42001. One of the main places is with MAP 1.1 under the NIST AI RMF. And so that ARMF subcategory is it's a big one where you do work to characterize your context. What is the technology we're using? What are the locations where we're using it? How is it going to be used? Who are the potential users? What are some of the communities that might be impacted, and so on. Some of the places where in 42001, where MAP 1.1 corresponds is 614, B52, and so on. I won't read everything off the screen. One of the important aspects of impact assessment is stakeholder engagement. This is something that should not be done in a vacuum. It shouldn't just be people sitting around a table making things up using their own judgment. They should be talking to again those potential users, where relevant, potential communities that could be affected, could be impacted. And so in the ARMF, that some of the subcategories where you do some of that are MAP 1.2 and MAP 5.2, and you can see their correspondences to parts of 42001 as well, including the clauses for AI system operation monitoring and external reporting. All right, I'm going to turn it over to Deminda at this point to talk a little bit more about some of the ways that impact assessment can focus on specific issues such as potential misuses, security issues, and so on.
Thank you, Tony. So as Tony mentioned, I will get into some of the misuses. And I think previous speakers like Maria and Kim gave us great examples for us to use. So misuses is actually like in most cybersecurity issues, it depends on how aware or technically astute you are to get things done. For example, Mariel mentioned the not to violate cultural abilities. And we also know that misuses and failures are linked to each other and connected to each other. For example, we might have recognizing the wrong people, or we may have some environmental conditions such as lighting, rain, snow, fog, and dust that impact negatively in identifying the proper person. But as all of us know, now there are better AI systems that are like deraining, defogging, desnowing algorithms. If you use one of those algorithms against someone who wears a hijab or a hat and try to remove that hat, they may not like you recognizing what you actually eventually detect. We can go to the other extreme and say, I'm going to use a camouflage removal algorithm on everyone. I don't think anyone would like this type of misusers. So this is exactly why the standards matter, and your adherence to standards that will eventually make people accept that the fact that you're dealing with is actually a ethical, standard compliant organization. And that also would give us this limit of false accepts and false presence, like where are we working, the context in which you use the AI algorithms, how far will you go to avoid a false, and so on. The second aspect is also the safety security that has not been resolved very well, but we are in the process of learning from our technical capabilities, bringing them into the standards. I think the best example I could give you is that you could go and read the Fukushima Daiichi, the nuclear accident. It was very well analyzed. People did their best. But after the accident, we realized that nobody expected a 70-foot high tsunami. It was never analyzed for that case. So the analysis was not bad, but that was a misuse case that did occur. It was beyond and above the risk analysis that was done. You can read this detail in the National Academy's 2 reports on it. So I know that I'm getting examples from one extreme end for misusers, abusers, and false evaluations, but it is all possible. We learn from what we do, and we also want to agree to what we in fact can do at the current time with the best science that is available. The second aspect is that identified potential impacts to individuals and groups of individuals. That would include fairness. This, as Muriel and Tony mentioned, this could be basically based on how people look. Not only could we not use cultural or other recognizing features that have agreed not to use, but also features like if you're in front of a camera, you move around, they could get your gait too. You could be recognized from the gait even if you don't have the face recognition system, or the face recognition system fails, but you never agree to recognize people from their gait, so which you should not do. So there are these issues of fairness, because now you could be recognized for some other purpose and some other place and say, oh, I know who that guy is. This is the only person who walks like this, or that's the only person who smiles like this. Those are not agreed upon standards. So that is the fairness that we need to do for everyone's benefit, everyone's privacy, and everyone's security. Thank you, Tony. Next page, please. Next page. Okay, thanks. So in the NIST RMF, in the section 5.1, likelihood and magnitude of each identified impact, both potential benefits and harmful, is based on the expected use. This is exactly what I mentioned earlier. you saying this is how I'll use it. This is very much like the usage of data that were collected for healthcare purposes. There is a purpose. And based on that purpose, you say, this is only how I will use it. And past uses of AI systems, similar in context, public incident reports. We know all the misuse cases was using that have been collected of misuses of, let's say, medical electronic medical record systems, and we do our best to prevent such excesses. We do our best to log those excesses, as Kim mentioned, and ensure that those logs are proper and that we have not gone beyond what we agreed to. We could have a similar system for AI, and that's exactly what this NIST RMF says here. So these are external to the team that developed it. I think before Muriel mentioned that the development team is not the validation and verification team, and also not the team that data that are identified in the document. So those are the things that we actually need to work on. And on the other hand, if you go to 4201, you can see that in 6.2 and B5.2, they do mention about AI risk assessment and the impact of the assessment process itself. So this is where that issues with the negative samples, the extreme examples that you can use. One of the great things of AI is that you could use it however you want. You could develop a technique that's very useful in one example and try to bring it in something else which you never agreed to, and violate all those safety, privacy, and people's ethical agreements to use technology. So those are both things that we would have to recognize, and you can see the matching from NIST RFM to ISO IC 4201. Next one, please. All right, so false accepts and presentation attacks. I think, for example, we could also use this data to create deepfakes, and nobody wants that. For example, what you see speaking here is me. It's not one of my artificially created avatars, in which case this talk makes it would be a very bad thing. And on the long term, people would essentially distrust this type of forums. So that is why the risk of using information or information that looks similar to some other information with respect to some detection algorithm, you could always look at the similarity concept and make up something that will bypass the algorithm or be accepted by the algorithm, but was not the real thing. So those are some of the risks that we do have. And they have consequences. As you know, deepfakes have a lot of consequences. Everybody talks about these days. And the question is, how likely is that, and what kind of aspects will we go into when we try to discuss this type of systems? So we go back to the face recognition system guarding the entrance to a building. We could use such a system. We could get the information. We could create deepfakes. So everything is possible. But the standards that we agree to say, no, we are not going to do that because we believe in everybody's privacy. We believe in adherence to the standards for the common good of everyone, including the person who thinks he or she can create these extraordinary capabilities to violate the existing standards. So essentially, if you look at, and both of these actually apply in context, as mentioned by Tony earlier, if you take anything out of context, because this was supposed to be used here, but I'm using it there, but I don't exactly know why you have to do that. Maybe to improve an algorithm, maybe to improve the detection possibility, but there's a limit to that. It also allows you to go to the other side, which is what we don't want to do. And we want to make sure that the community that agrees to these standards adhere to these standards, and they subject themselves to audit and test, verification, and validation. So as last figure, we show the risk assessment capable metrics with respect to likelihood and consequence. And I think Tony did a great job in color coding this, so I don't really need to even read this one. That brings me to the end of my talk. Thank you very much.
Thank you, Demenda. Thank you so much, Tony.
Thank you.
There is a quick question in the Q&A about the existence. Is there a AI risk library, for example, risks to consider for accuracy, fairness, and data quality? Does anyone know? Do we know? Is there a list of potential risks?
But that should depend on the technique you are using, right? So for the ones that use for voice recognition, may not apply for face recognition or gait recognition.
True.
One thing I would mention is that I think there are some resources both in the NIST AI RMF playbook and like, for example, under measure 2. Well, some of the subcategories under measure 2, the AI trustworthiness characteristics, for example, 2.7, measure 2.7 for security. They can point to some resources for particular ways to characterize security. And I believe there are a number of ISO standards and technical reports and so on that can also be informative and useful there. And the AI RMF playbook points to some of those, as I think Elham mentioned in her answer to one of the questions. Speaking of measure, I believe that is next up, Greg Cannon. So I'm going to stop talking. Thanks.
Well, we are right on time. Thank you both, and very glad to welcome Greg Cannon from Amazon Web Services, where he represents AWS at the INCITS board, where he's a highly valued member. And Greg is going to take us into a discussion of specific measurements. The metrics matter, and Greg is going to lead that conversation. Please enter your questions into the Q&A, and we are in the home stretch. So thank you all, everyone, for sticking with us. We're 2/3 of the way through, and thank you, Greg.
Thank you, David. I'm very excited to talk today about risk management in the context of the NIST AI Risk Management Framework and its relationship to AIMS. I'm responsible for driving biometric and AI standards at Amazon, at AWS, been engaged in the development of secure biometric solutions and standards for about 20 years. I'm the convener of SC37 Working Group 4 for the technical implementation of biometric systems and the chair of the FIDO Biometrics Working Group. We're talking about measure. It's in NIST AI Risk Management function, framework talks about it as the main activities of identification, evaluation, tracking, and they overlap with very high-level management activities of AIMS, the planning, operation, evaluation, impact assessment, verification and validation, monitoring, and data management. This has already been covered, just basically level setting. So also, we're going to reuse some of these risks that were just mentioned. We've got performance problems, either accuracy or bias. System might put people at insignificant inconvenience. We've got a privacy risk. The biometrics collected for enrollment could be associated with identity. They could be breached. We've got a scope creep kind of risk where biometrics, which were intended to use for physical access control, might be used for something else, like time and attendance or security incidents response. That would be done inappropriately. For my presentation, I'm going to think of these risks from the viewpoint of 3 different stakeholders. First, we have an algorithm provider. This is the organization that might actually develop the facial recognition model. We've got a solution provider. This is the organization that would basically integrate the facial recognition model along with the IT systems and the door locks and the cameras to actually develop a facial matching building access control system and install it at buildings. And then we have the system operator, and they're involved with actually operating that access control system that the solution providers provided. We're going to use these same stakeholders as we measure each of these risks in turn. What we've done so far here is we've basically prioritized risks. And by going through the risks that we've just been mapped and considered from an impact assessment perspective, we're already starting to go through the NIST AI Risk Management Framework. So we're we're using 1.1, and that's mapping into AI AIMS risk assessment requirements, the 6.1.6.1.2. We're considering approaches for personnel and documentation. We're documenting approaches from consulting with domain experts and stakeholders. And as we start to go through these initial measurement activities, we see some coverage of both the risk management framework and the AIMS requirements, especially in clauses 4, 6, and 8, the controls in B.5 and B.6, among others. We're going to go through this same kind of a framework as we go through the other risks, but this is basically just the initial level set. We've prioritized risks. We've thought about what it actually means from our context, and we're thinking about how we're going to put measurement systems in place to deal with these risks. So let's get into the first one, right? So the algorithm provider, we've got some accuracy issues of what are we going to measure. The algorithm provider has decided, all right, what do? I need to measure accuracy and bias. Let's look for some standards. There's some standards that exist. ISO 19795-1 for performance assessment, and also emerging standards like the 19795-10 for differential impact or bias. Since the use case that Kim went over is talking about a 1 to N use case, i.e. you go into the building, you don't have to present your credential, it recognizes you and lets you in or alerts you when you're not. That's a 1 to N match. So the correct metric is not really false reject or false accept. It's false positive or false negative identification rates, failure to enroll, and failure to acquire. They'll measure those things with respect to the ISO standard for 19795, and they'll measure bias with 19795-10. This being their area of focus, they have access to a lot of data that they've used to train, and they have access to validate and to test. They'll have a lot more data than certainly the operator will to actually deal with the problem associated with measuring bias and measuring accuracy. Solution provider also needs to look for published standards. They need to be thinking about how am I going to think about how this system might actually work in a real deployment environment. So they're going to look at 19795-2, and they're going to think about how to measure bias from their perspective, maybe without the benefit of all that data. The operator has much less data and has to choose to report like false negative identification rate incidents per group. And that's the measures that each of these stakeholders would actually find appropriate to try to measure that risk over time through the life cycle of the development and deployment and reduce it. Let's deep dive a little bit. So that the algorithm provider is dealing with protecting human subjects used in training and testing data sets. The service provider is dealing to make sure that their measures are relevant to deployed settings, and the operator is dealing with monitoring performance problems in production. And we're thinking of appropriate metrics involving non-developers. We're considering trusted stakeholder measurement methodologies, all of those activities in the 2.x series of the NIST AI Risk Management Framework measurement section, and we're getting feedback processes in place. I'm going to call out a few especially, right? So we're evaluating human subjects, that's 2.2. That maps very closely to the AI verification lifecycle controls in B.6.2.4. We are documenting quantitative measurements associated with accuracy, and that maps to these requirements associated with monitoring requirements in 9 and lifecycle controls in B.6. We're doing measuring functionality as in production, requirements in section 9, lifecycle controls in B.6. And also, this is that we just mentioned, had a discussion on this on fairness and bias, assessing impact. And then, that's directly maps to controls that are in the AIMS management system for B.5 and B.4. And as we work through those processes, so we can see that, we have a different perspective of both the risk management framework from each of these stakeholders, but together they're covering quite a bit of ground, right? And there's a few holes left of the AI risk management framework. And together they're also meeting a lot of coverage for the requirements and the controls of 42001. And so it's a great way to think about how what you need to do is really focused on, like what the NIST AI Risk Management Framework talks about, that context that was discussed last time in Mariel's presentation. Let me take a little step backwards on bias. So I'm sure you've heard the saying, "What gets measured, what gets is what gets done." And NIST has been measuring bias and facial biometrics for several years now, with the result being notably reduced bias in facial matching algorithms. Measurement is a great example. Measurement is crucial to risk reduction, and the more quantitative, the better. And Elham spoke earlier about risks as the effect of sort of uncertainty. It can be harms or benefits. I'm not the first person to say it, but using AI to improve bias is a strong benefit of using AI. I think a lot of people would say, oh, well, we have to worry about bias as a potential harm, but consider the alternative, right? The alternative solution is having a human, right, be accurate and be unbiased and measure that human's performance, right? Unlike humans, it's relatively easy in AI to set objectives, to train, to measure and improve. And AI probably gets better than humans when it comes to bias and accuracy. We are really not working so much to reduce a harm as to maximize a benefit. I'm going to move on to the next risks, right? So we have the privacy risks collected for enrollment, could be a breach. Where the service provider is dealing with the brunt of a privacy breach in their one-to-end database, and the service solution provider and operator creating responsible with more quantitative measures that correlate with the problem. Similar to our last thing, we're going to focus on a few call-outs here, right? The privacy risk of the AI system is identified, and it maps to in the AIMS alignment, it really maps to aligning with other organizational policies, especially something like 27701, a privacy management system, or 27001, which might be more appropriate in a sense, and so you don't need to reinvent the wheel when you're dealing with certain things like privacy risks. And the other thing here is that we're starting to think about things that are a little bit more challenging to actually measure. So we're documenting, we're considering approaches for risks that are difficult, and that's in AIMS. That's this 3.2, but in the AIMS, it's these requirements in 10.1, and then the controls of B.6. So we're starting to see a slightly different coverage map, as we work through this kind of risk and allocate it across these stakeholders. We're covering the risk management framework in a slightly different way, and similarly for the 42001 standard. Moving on to the third risk, we have the scope creep issue. Here, the algorithm provider, I think it's interesting, is really not really in this game, right? Their face matching is not relevant. They design it for very broad application, including potentially time and attendance and post-security incident forensics. So, asking them to make sure it doesn't work for that, or even consider that, is really not appropriate. The algorithm provider would say, if you want to use it for that, that's fine. It's the solution provider that's really bearing the brunt of this, because they're making that business decision to actually implement this. And so we're going to have to really lean on transparency, I think, to actually think about how we might manage and then measure how those transparency mechanisms are actually being effective with respect to reducing risk. So I'm not sure this is the right way to do this, but you're being creative, right? So we're trying to figure out how we're going to document measured counts of logged access and intended use documentation, and make sure that we have a commitment, showing a continued commitment by the operator and the solution provider to the intended use, and to make sure that the scope creep is important to both of those people, and make sure that the end users are informed, and to measure the effectiveness of those mechanisms. And similar to the last thing, we're working on things that are quite difficult to accomplish in terms of measurements, no standards associated with how scope creep might actually work. But we're going through the best practices of both standards, and which talks to how you do this in an effective way. So we have the NIST AI Risk Management Framework, the 2.8. We're talking about risks associated with transparency and accountability, and how they map to those 42001, especially those lifecycle controls in B.6.1, and the objectives for responsible use in B.9.3. And very different mapping here between the stakeholders, as the algorithm provider is not involved. So, summarizing, there's lots of overlap between 42001 and the NIST AI Risk Management Framework. In fact, actually, in my measurement. Okay, the crosswalk that was put together by Kim and in this walkthrough that I went through, we actually had, if you were able to do 42,001, just even a subset of 42,001, like the summary is showing, it actually covered AI risk management framework. Some of the questions that were asked earlier, I think if you were to actually start with 42,001 and consider those controls and make sure that they map to some of the activities in the NIST AI risk management framework, you'd find you'd have coverage, at least this one activity measure, you would have coverage going the other way. And certainly when you think about how you implement those controls, if you just put a little bit of effort to actually examine the NIST AI risk management framework for other guidance and other expected documentation, I think you would actually meet a lot of both. So I'm actually a fan of doing both. I think both really help encourage responsible AI activities for all stakeholders in the ecosystem. My main summary here is adopt standards for risk management activities. Risk management should be done in the context that makes sense, and wherever you can, go quantitative and leverage other standards and trusted resources to effectively manage risk. Thank you.
Thank you so much, Greg. You were so efficient that we are 1 minute ahead of schedule, and we have time for one question here. That question is, who is responsible for determining the cleanliness of the data used in the original training model B7, perhaps? This question of data used in training models, I guess, would be particularly appropriate to the pre-training now that is dominant in generative AI. Any thoughts on that?
Yeah, so I mean, sure. I mean, in my little toy use case here, that the principal responsibility for that data cleaning is, relies on that algorithm provider. If we're talking about data for the biometric, for the AI model, right? So, but data is relevant to all of those stakeholders, right? So we've got, especially if they bring other AI systems into play, right? So whoever's actually dealing with training, testing, or validating data, like say maybe the solution provider has plenty of data to actually test the biometric data. They need to clean that data if they want to use it to test a new version, perhaps, that the biometric algorithm provider provided, right? So it's like, okay, we like this algorithm provider, works pretty well, but we still want to trust and verify. We have the data now, or we've invested in data, and we want to make sure, test, just audit perhaps in a testing way and measure themselves. And if they want to do that, then they're going to be responsible for assuring the quality of that training data. And so it's about trade-offs, right? All these measures and mechanisms cost activity and effort. And so what's the expected benefit? Does that really reduce risk? There might be other risks that and other mechanisms that you might want to invest in. And organizations and all of these frameworks, they are given the discretion to make the right decisions, but the idea is to encourage them to do so from a risk management framework perspective. Hope that makes sense.
Yes, thank you so much for that succinct answer for your presentation, and we'll thank Chris for posting that question. That brings us now to Dr. Stephen Kwan. Welcome, Dr. Kwan. Dr. Kwan, in addition to being Professor Emeritus at San Jose State, is a valued member of the U.S. TAG for Artificial Intelligence at INCITS.org. So welcome, Dr. Kwan, for your discussion to take us into the manage example.
Thank you, David. So I'm just using the same use case that's been used and go through it with the management examples from the AI RMF and also the AIMS document. So in the first part right here, I labeled a group of items here. I called it Professor. I think in Greg's presentation, he called it the algorithm provider, which is the people who actually developed the system itself. And then I will have also the other two components a little bit later on. So let's look at this part right here. So in the AI RMF, there is a management 1.1, which is to determine whether the AI system achieves its intended purposes and so on. And there is a equivalent set of items in AIMS, the B 9.3 all the way through B6, 1, 3, 2, 4, and so on. So those are very synced together. Let me go through the second one, which is Manage 1.2, the treatment of document, AI risk, and prioritization. Here, I want to add a few more items here. So on 6.1.2 in AIMS, we talk about the AI risk assessment. And in Mario's presentation of MAB, we will see that 5.1, 5.2 relates to that. And in Greg, in the measure part is 1.1 and also 2.8 is already related to this. And if you look at the highlighted area here, given the AI policy and objectives, you need to identify and analyze the risk. The risk, and you can see the examples from Tony and Dominda in the risk and impact assessment, the whole list of risk. And also, Greg has also mentioned 3 specifically. We're going to use that to assess the likelihood, levels, and consequences of the risk, and then evaluate, prioritize the treatment, and also document the assessment. The third part right here, Manage 1.3, is how do we respond to the risk? And there are deemed high priority, and you saw the last slide from Dominda about how to kind of categorize the high probability and high impact on some of those risks. And here, I think that it's very important for us to remember that to use this AIMS, we need to look at some of the controls that are kind of documented in Annex A, which is a very long list. And if we're actually doing it, that's a very good resource to go to help us document the controls. And also in Annex B, there is a very good guide that can be consulted for implementation of this controls. So the management is, this is the management one. And then finally, the fourth one is the 1.4, which is dealing with the negative residual risk to downstream acquirers. In my presentation, we call them the customer users and the solution providers and so on. So the next part right here is the middle part of the use case. That covers the manage 2 and 3, the build and validate. I think Greg calls this the solution provider. This is the middle part. So if you think about it, it could be the cloud service provider. It could be the third-party solution provider, people actually implementing the system into the entry system. In the end of this slide, in the end of this deck, there are more details to the management 2 and 3. I decided to not go into that level of detail in this particular slide. You can look it up when we post this slide. I do want to go into the last part, which the management part, the management 4 part. This is where the system is being deployed, used, and also needs to be monitored. I call this group the customer user. I think Greg called them the operator, the people who are actually operating this. So what do we have here? We have management 4.1. What happens if you post deployment? After you're using the system, how do we monitor it and seeing that the plans are implemented? And also, how do we capture, evaluate input from users and other actors? How do we do appeal and override, for example, if the system has an error or we feel that the system is not operating correctly? And in this case right here, in B626, the operation and monitoring, system and performance monitoring, response to errors. And I think that Tony has mentioned that in his list. What happens if the system has an error, or was the weather conditioned, or the system fail, or there is a power failure? So some of you might have also experienced when you try to use a system like this, and there's a power failure, and we have lots of that in the West Coast in the past year. And what happens if you cannot enter a building? What if there is an emergency, there's a fire, and the fire department comes in and there's no power, you can't enter the building, and so on. So there are a lot of issues related to that, and that has to be assessed and make sure that's part of your planning in the implementation and monitoring. There was also mentioned of the data drift. I believe that the also data drift and also scope drift in a system like this, and a few other things that need to be monitored and so on. The next part right here, management 4.2, measurable activities for continued improvement. That is really something that needs to be done for any system for a continuous improvement, but that's also important for AI system as well. So the last item here, 4.3, how do we communicate the incident errors to the AI actors, including the affected community? So there are people who might be have false negatives and things like that, and they are rejected based on bias or not the system not operating correctly. How do we deal with this, and how do we communicate with the communities that are being affected, and so on? Okay. So finally, I want to indicate that if you got a hold of the slides, there are a couple other slides in the back that talks about management 2 and 3. Thank you very much. David?
Yes, thank you, Dr. Kwan. If you have questions for Dr. Kwan, please enter them in the Q&A, and we will make sure that we get those. But we appreciate your participation in the committee and your support in the U.S. delegation and for your presentation today. Next, we have Riva Schwartz from NIST, a worldwide expert on bias in artificial intelligence. And while Riva's getting teed up here, I'll give you a couple of interesting tidbits about her background. She is recently named to the ABA, the American Bar Association Task Force for the Law and Artificial Intelligence, or Artificial Intelligence and the Law. Additionally, she is a Gator and was also working in linguistics at the Center for Excellence in down the road here at Johns Hopkins University, which is the Human Language Technology Center of Excellence at Hopkins. And it's easy to see how that would be her transition into bias in artificial intelligence, because language is one of the layers at which bias presents itself. Do we have Riva available here?
Yeah, David, I will cover for Riva on the conversations of the measurement, and we don't have any slide. I'm conveying Riva's regret for not being able to be here.
Thank you, Ellen.
And I tried to do justice to what Riva wanted to say. So I think, and I don't know how much time we have, but I'm going to talk about from the socio-technical lens from the AI RMF. I believe I mentioned in my overview of the AI RMF that there is a lot of emphasis in AI RMF that AI systems are not just about data, compute, and algorithm, but about data, compute, and algorithm and their complex interactions with the context, with the environment, with the human and individuals that are operating it or are using the systems, or knowing or not knowingly being impacted and influenced by the AI systems. To that end, measurement of the AI systems cannot be just from the computational lens. Almost exclusively all of the evaluations that we have been done at NIST, including the biometric evaluations that some of you on the call may be very much familiar with that. We take the AI systems, we take the systems under test. We haven't done much of this AI system evaluations. outside of the context of use, bring it to the laboratory, run the test data that may or may not be representative of the actual real world use case, get the results, get the output from the system, run through the analysis, apply metrics that may or may not be robust and reliable or well-defined, and plot graphs, and that would become the AI evaluations or the system evaluations. We are of the mind that those are not going to be sufficient for AI systems because we heard a lot about the need for understanding and measuring risk and impact, and those type of evaluations are not going to even get close to understanding the risk or measuring the risk and impact. To that end, we have been doing a lot of thinking, reading, consulting on figuring out what's the right approach to evaluations of the AI systems in a socio-technical approach that allows for assessment of AI risk and impact in addition to AI capabilities and functionality. I will also say that in the continuation of the work of the AI RMF, I talked about the development of the the crosswalks. I'm sorry, the profiles, and I probably mentioned that we launched a generative AI public working group at the end of June to develop a cross-sectoral profile of AI RMF for generative AI. We kind of basically selected a subset of the guidelines in the AI RMF and work on them to issue 4 sets of guidelines. One is on the validations, pre-deployment validations of the models. As you know, the companies that are generating and releasing these large language models are releasing also model cards that at different and varying level of detail document and report the type of testing that has been done pre-release. Most of them, or almost all of them, are using red teaming to do this. So the sub-working group of the Generative AI Public Working Group that are working on development of the pre-deployment validation guidelines are going to consider red teaming, but hopefully also broader than red teaming. And the end goal is development of an industry norm practices for how to do the evaluations of and verification and validations of the models, generative AI models, pre-deployment, pre-release. So that's one set of activity on developing the guidelines that gets into the, again, support of the AI RMF in terms of profile. We are thinking about what are the methods, metrics, test environment needed for AI risk and impact assessment. And we are also thinking about possible challenge problems that has to be done. The work of the Generative AI Working Group has been very active. We decided to take all of the work in the collaborative spaces. There are Slack channels. The attribute of the process is similar to the development of the AI RMF, open, transparent, collaborative, but we just didn't have the luxury of the time element that we had with AI RMF. When we started the journey of AI RMF, 18 months sounded too short of a timeline, and now we are wishing for 6 months that we don't have. But at any rate, having it at Slack channel allows volunteers to work on this asynchronously. Each of the, just like AI RMF, eventually NIST has the pen on writing this, and we'll have it out for public comments. I'm just going to stop there and answer any questions that anybody may have. As we're thinking about your... I was going to say one other thing. Earlier you asked about, is there any catalog of incidents or errors or sort of a catalog of risk? Just want to point out that another sub-working group within the Generative AI Public Working Group is on incident disclosure. That is learned, borrowed ideas and thoughts from cybersecurity, from nuclear, the importance and the value of having disclosing incidents and having catalog of things that can go wrong is helpful to the community. Sorry, I want to mention that too.
Very good. I have a question myself. In our ideation exercises around the risk library, or the risk taxonomy, as it's sometimes referred to, are there limits to how far we should allow our imaginations to wander? Is there a risk of coming up with a misuse that might otherwise lay undiscovered for a long time? Have you considered that?
Right. I should also mention that OECD has a similar activity on, I think they call it incident database, and the way they're doing it are basically collecting that type of incident that's happening from kind of news media, from the reports are coming out of the industry. So basically, it is the one that OECD is doing definitely based on the things that has happened rather than the things that can be imagined. The generative AI public working group, I have to say that I believe that that's again the idea. We want to ground that into things that has happened rather than the imaginations of the things that can happen. This also gets into the definition of incident and how you define incident. And OECD spent a long time on working on that definition.
Well, I will open the floor now to other panelists if there are questions that others would like to pose, since we're slightly ahead of schedule. Please feel free to jump in here, because the final word today will go to our chairman, the chair of INCITS AI, Rohit.
Maybe I can also mention one other activity that's so OECD, undergone with OECD, we support that, and that is a hub for metrics. So they basically start working on a catalog of all of different tools for any sort of measurement of AI systems and put them together. There's a lot of value and merit on putting all of these informations in one spot, but what's lacking is also doing some sort of the assessment on or some sort of annotation or labeling of the quality of those tools. Are they working fine? Are they generalizable? Are they fit for purpose? So that's some of the things that's happening, discussions in the OECD. If you go to our resource center, airc.nist.gov, you would see a link to the metrics hub that we support OECD in development of that.
That is an excellent point. And we have a question now, or a comment from Lenora. Lenora from Google. Can unmute yourself and join the conversation.
That was actually an accidental hand raise.
That's okay. It's a reminder that in technologies mistakes can happen, so we need to protect from any circumstance. There is a question in the Q&A. However, the question reads: Is there maturity levels within this framework model to measure/manage level for organizations to achieve high value assurance and safety? Maturity levels is the question.
I mean, so, and perhaps Elham could answer a little bit more strongly from the NIST standpoint. I know from the 42001 standpoint, it's less about maturity and it's more about, what makes sense for your organization from a risk standpoint, but then also it's general enough and provides implementation guidance so you can make it as granular as it needs to be to achieve, you know, compliance with not just with the document, but with applicable regs and laws, where you may need to have more detail when you go into that, you know, those controls and you're documenting what you do, etc. I don't know, Elham, do you have anything you want to add to that from a NIST perspective?
Yeah, I have to admit that I'm not quite sure what the maturity level means, but we wanted the framework, again, be general technology and sector agnostic, and be sort of the a horizontal approach for risk management to all sectors, and then build the verticals, which is going to be tailored set of AI RMF guidance categories or subcategories for a particular use case, or you know, cross-sector or for general purpose systems. And I think a lot of those sort of granularity, we left that for the development of the profile. We give some suggested actions and some sort of supporting materials, including informative references in the playbook. But those type of getting that level of granularity, as we're doing it with a cross-sectoral profile of the generative AI for AI RMF, we envision that it's going to be in those verticals. If I understood the maturity level, I hope that answer was helpful.
Thank you. Thank you so much. Anyone else would like to jump in before we hand the closing word over to our chair? I'll just say my thanks to all of our panelists. We thank you so very much for joining us today and representing your organizations. Rohit, are you ready to bring us home?
Mute me. Yes.
Yes, we can hear you.
All right. And I have a couple slides. Okay. Well, just to wrap up, so today's workshop is a very important workshop, and there's a reason why we're also recording it, and hopefully we'll be able to share this material. And it's the first kind of workshop we've had where we've actually laid out some actionable steps. There have been some conversations, and again, there's been a lot of work that's been done. And this workshop in particular, we used a real life use case and put together, the steps that one would take, both to align with the NIST AI risk management framework, and also we provided the 42001 AI management system, how organizations could document and confirm to what would be a management system standard, and very important standard. So both these put together are like the first actionable steps that organizations could take. And we also shared the crosswalk, which will also be made available. And we did this through a live example of what is a use case, which sometimes gets criticized, which is facial recognition. But here for like entry in a building, overall, I think put together, there is a place where one can see, based on the workshop, that you can implement responsible AI and document it. I also shared in the chat window a couple of links, and one of them is actually a link which has got a lot of work that's being done by the SC42 committee. It has a link to all the other projects and the standards that are in process. And you can see there's a lot that's coming, and our intention is to have this workshop as the first one in a series of workshops to educate the ecosystem of how they could use standards. We will certainly be having the next workshop on auditing. We will let you know the date, and we'll be sending you a feedback request form for this workshop in terms of getting feedback from you. And if you want to be a part of the standards organization, please do reach out to INCITS AI, And we welcome its standards in the US. A voluntary government and corporates participate together. And at the SC42 level, which is the international levels, all the major countries involved in AI are participating in these international standards. So it's basically a place where there is an ecosystem approach that has been taken. Besides the AI standards, the link to which I shared, there's all the aligned work that happens with JTC1, which is the rest of the ICT standards. And via Liaisons, SC42 is working with all the other subcommittees too. I also shared a link to a workshop we're having at the ISO level, which while the SC42 chair is chairing, and that workshop has more engaged conversations around both emerging trends and it's a way of engaging with what's next within the AI ecosystem. So please do register, and we welcome your participation in that as well. We thank you so much for your participation, and we'll be sending the material over to you. Thank you.